right, so in last time's lecture, we finally got into section 2.1, which is the core part for the chapter, for the textbook, for the material we cover, rather than doing the um, the review version. So now we're getting a little more technical. We're getting other kinds of exercises. We evaluated a few functions, well, for different values, and letter and numbers and variables at the same time. So we were left with one more example, letter F. So they're asking us to evaluate F at x plus 4. So again, to briefly summarize what we did last time, so we were given a function, and they were asking us to evaluate it at different numbers, at 0, -2, at -x, and then a combination of a letter and a number. We're going to do another combination letter and number. So, for example, for instance, so we're going to do, um, so that's going to be 3 times quantity in parentheses divided by 2 times the quantity squared plus 5. And we're going to replace the quantity here with the x plus 4, which is that quantity inside of parentheses that it's being asked to replace with, what we have inside parentheses. So let's do the required operations here. So, okay, so for the numerator, how about we distribute the 3 over the 2 terms right here? And well, for the denominator, I'm going to notice this x plus 4 quantity squared. Well, there's a couple of ways to expand this binomial. So, well, number one, that's going to give us 3x plus 12. And then divide that by 2 times. I'm going to rewrite this x plus 4 squared as x plus 4 times itself. And then plus 5. And here, what we're going to do in the denominator is FOIL the product between these two binomials. That is x times x and then x times 4. That's going to give us as a result, well, in the numerator, we still have the quantity 3x plus 12 over the quantity 2 times, be careful, so in this case I'm going to open brackets and I'm going to do the result of getting x times x, which is x squared, and then plus 4x, and then I'm going to do the second part of the foiling here. I'm going to do, so 4 times x times 4 times 4. 4 times x, which is another 4x, and 4 times 4, which is 16. Let me close the bracket and just bring down this positive plus 5 that we have at the very end. All right? So from here, how about, so that's a 3x plus 12 in the numerator still. That doesn't change at all. And well, let's combine 2 times, okay, combine the like terms inside of the parentheses. That's x squared plus 8x plus 16. And add the 5. All right? So we still have a couple terms to simplify the denominator. Number one, you might want to distribute the 2, and then we are going to see some constant values that will work as like terms. So again, let me indicate that distribution here, that'll be 3x plus 12, so that's a 2x squared plus 16, x plus 32, and then plus 5. And simply at the very end, combine 32 plus 5, that's going to be 37. Alright, that's going to be 3x plus 12 divided by 2x squared plus 16 x plus 37. And well, in this case, there's nothing we can simplify about this because, well, even though we can factor out a 3 from the numerator, there's nothing we can simplify any further from the denominator because 2, 16, well, these two are even numbers. We can factor out a 2. However, unfortunately, not for the number 37. So that's pretty much a simplified function over here, right? So we're done with this one. All right, so again, in summary, we can evaluate a function not just at a numerical value, but also at another symbolic number, or rather symbolic value, or combinations of symbols and letters variables. So, and letters E and F illustrate those ideas about how we can evaluate a function at a letter and a number at the same time. All right. And well, what's the next topic is about precisely about evaluating a function at a given at a combination of symbols this time. So this is what we're going to call the difference quotient. Okay, the difference quotient. It's that formula f of x plus h minus f of x divided by h. Well, that's this formula is going to be our very, very basic foundation for calculus. It turns out that this is related to what we're going to look later in calculus called the derivative, for which we will construct a lot of ideas that will be used to later construct other ideas in integral calculus and that's going to be a really big field of mathematics here. However, well, we need to understand how this different quotient works, but most importantly, how to go about the algebraic simplifications, because I'm not gonna lie to you, these ones are going to be a little tough to do. So yes. So in this case, well, the difference quotient, it's defined by the function evaluated at x plus h, and then minus the original function, and then divide the whole thing by h. So we're going to evaluate the difference quotient for the given function right here. All right, 7x squared minus 3x plus 8. And let's see, so number one, we need a couple of things in here. Number one, we need to evaluate f of x plus h on the one hand, and we also need the original function f of x. Right, so two quantities here. Let's evaluate the f of x plus h first. So f of x plus h, that means wherever we see the letter x, I'm going to replace it with x plus h. All right, here we go. So that's going to be 7 times parentheses squared, that's going to be x plus h, minus 3 times the quantity x plus h, plus 8. So that's the setup. Let's go about simplifying all these polynomials. So again, in this case, we will need to expand this binomial. We can do it by foiling it. So that's a 7 times x plus h times x plus h minus 3 times the quantity x plus h plus 8. Well, for the second term, we can simply distribute the negative 3. And well, here we're going to do a foiling x times x and x times h. So let me do one at a time. So number one, let's keep the 7 in the very front, 7 times. I'm going to open parentheses, and I'm going to write the result of foiling these two, that is x times x, which is x squared, x times h, that's, well, in alphabetic order, hx. So that's the foiling of the first two. Let's do the same over here. Now we're going to FOIL the h with the x and h with the other h. So h with x, h with h. And what else? So okay, that's going to give us plus hx and then h times h plus h. All right? So let's see. And then over here, when we distribute the negative 3, that's going to give us a negative 3x minus 3h plus 8. And we're almost there at only for the f of x plus h. So let's see, what about it? Oh, it was yellow.
It should be like h squared.
H squared, that's correct. Thank you. H squared. So now we're going to distribute the 7. Oh, first we combine the like terms. That'll be 7x squared. Okay, parentheses, x squared plus 2hx plus h squared minus 3x minus 3h plus 8. All right, now let's distribute the 7 over all these parentheses, and this will be okay, so that's 7x squared plus 7 times 2, that's 14hx, plus 7 times h squared, that's 7h squared, and this is going to be minus 3x minus 3h plus 8, right? So, and actually, well, there's nothing to simplify here even further, right? There's no like terms at all. However, they will be once we combine them together into the difference quotient here. So now, okay, let's evaluate the difference quotient. To evaluate the difference quotient, well, let's write the formula first. F of x plus h minus the original function f of x, the whole thing divided by h. So, well, that quantity f of x plus h is all this madness we have over here. Let's just rewrite it. Just write it down again. That's going to be 7x squared plus 14x, or rather hx, plus 7h squared. And then minus 3x minus 3h plus 8. And then, well, the difference quotient formula is also asking us to subtract the original function f of x. All right? So in order to subtract, okay, all we do is minus. However, notice the original function is comprised by more than one term. It contains 3 terms. So just make sure to open parentheses and write the whole polynomial. 7x squared minus 3x plus 8 divided by, what's that? That's h. The whole thing divided by h. All right? Again, this whole thing, actually, let me change color so you can see it. Okay, so let me change this to, say, okay, the yellow one. This will be the yellow. That's the quantity we did before. And then let me change this to green. All right? And let me go back to the original colors. So this is what's going to happen. What's going to happen? Notice this negative sign will change the sign of everything inside of the parentheses. Please, no pictures. Please write it down. And let's see. So that's going to give us a 7x squared plus 14hx plus 7h squared minus 3x minus 3h plus 8 minus 7x squared minus minus becomes plus 3x and then minus 8. And then divide the whole thing by 8. And at this point, we can see a lot of terms, a lot of common terms that get canceled. So let's see. Notice how 7x squared minus 7x, and then what else? Notice the negative 3x and the positive 3x, and then negative 8 with positive 8. All those 3, or rather 6 terms get canceled. Okay. So we're going to be left with 14hx plus 7h squared minus 3h, and then I think that's about it, right? So that's going to leave us with, And we're left with anything else? No, I think that's about it. Okay, divided by age. So we will further simplify this expression, because notice how the numerator has a greatest common factor of age. So let's factor out the age times 14x plus 7h minus 3, and divide the whole thing by age. Over here, that's going to leave us with the quantity 14x plus 7h minus 3. And well, if you're wondering what about this result, yes?
I was going to ask if you could do what you just did again.
Oh, the canceling, or
When you went from 14hx to h parentheses 14x.
this part right here?
Above it.
Oh, right here?
Add to the one.
Oh, yeah, to factor out the, yeah. So that's what we do to factor to get rid of this h in the denominator. So just to give you the heads up about what you will be facing in calculus, this is what you will be doing during the first couple of weeks in calculus. And well, our goal, algebraically speaking, I don't want to get into the definitions because it's going to get a little too technical. So our goal is to eventually get rid of that h in the denominator, so we can compute that quantity for one big purpose that it's called the derivative using the limit definition. But well, it's too technical to get to the details of that. So for now, we're discussing the what you call the algebraic process to get through this. However, well, this one, let me just mention, this is like the easy case, the easy problem. These are gonna get a lot harder, especially when we do this with radical functions, with rational functions, and we will do it. However, before going through those examples, I'd rather take another detour and do a lot more preparation to get through that.